Bristol Community College, Mathematics with Dan Avedikian, Math 132, Calculus with Applications, Section 11.4, Problem 5. This is Section 11.4, Problem number 5. It says, use the formula f prime of x equals the limit as h approaches 0 of f of x plus h minus f of x over h to find the derivative of the function f of x equals x squared plus 3x plus 2. And once you've found that derivative of that f prime, part A, find the slope of f of x when x equals 3, and part B, find the slope of f of x when x equals negative 2. So, to get things started, I have my formula that's given in the question written out here with different colors. So we want f prime of x equals the limit as h approaches 0 of f of x plus h written in blue minus f of x written in red over h written in green. Those are the three parts. I write them in 3 different colors. So let's start with the blue part, f of x plus h, and calculate what that is. That's where most of the work is with one of these, finding f of x plus h. So f of x is given in the beginning of the problem. It is x squared plus 3x plus 2. And f of x plus h means use x plus h as an input. Every place that you have an x, replace it with the input, which for this is f of x plus h. So f of x plus h equals the x squared becomes x plus h squared, second power, plus 3 times x is 3 times x plus h, then plus 2. So that is the answer, but it really needs to be simplified. We can't leave it like that. So f of x plus h equals, so the x plus h in parentheses to the second power, you have to do x plus h times x plus h like that. That's what it means to have the parentheses raised to the second power. This is going to require that FOIL. And now the next parenthesis here, there's no second power. So I can just multiply the 3 in front of the parentheses times each piece inside the parentheses. So 3 times x is 3x. 3 times h is 3h. And now the 2 at the end is not in the parentheses, so it's just plain old 2. So to finish the simplification of f of x plus h, I need to FOIL out these parentheses here. So f of x plus h equals, so let me just write this in a different color to make it show up a little bit. X times x is x squared. X times h is hx. Then h times x is another hx. Then h times h is h squared. Then the 3x can just come down. The 3h can just come down, and the 2 on the end. Now again, that is the answer. I can combine some of my like terms, though. There are certain similar terms that I can put together. So as I look, x squared, there are no other x squareds. There's an h squared, but not an x squared. So x squared can come down by itself. And that's done. I'll cross it off. hx and hx again. These are the same, so I can combine them. hx plus another hx is 2hx. So now those are done. H second power. There are no other h second powers, so that's done. Cross that out. 3x, there are no other 3x's. There were the hx's, but not just 3x. So 3x, that's done. 3h, actually nothing else really combines now. Plus 2, done. So now f of x plus h equals x squared plus 2hx plus h squared plus 3x plus 3h plus 2. We've found f of x plus h, the blue portion of my difference quotient formula for the derivative. So now we can start filling stuff in. So we do this. F prime of x, what we call the derivative, equals the limit as h approaches 0 of, so now the blue part of the formula, f of x plus h, I have the answer over here. It is x squared plus 2hx plus h squared plus 3x plus 3h plus 2. Just copied it from over here. Then I have a minus. right there. Now f of x, which I've written in red, f of x is given at the beginning of the question. So in red, I will put x squared plus 3x plus 2. That's f of x. The question will tell you what f of x is. And I'll just make my fraction bar a little longer, put the brackets on it. And then in the denominator, h. There's not any work to do with the h. You just put it in. So now to find the derivative, we have to take the limit as h approaches 0. And wherever we have an h, we want to let it run down to 0. But the problem is the h in the denominator. We cannot zero out the denominator. That's undefined. So we have to find a way of canceling that h. So what's going to happen is any of the pieces in the numerator that do not have an h will cancel. There's a positive and a negative. And in order to really make that work, the f of x, always remember you have to put it in parentheses to subtract the whole thing. So now any piece that does not have an h will cancel, and the pieces that have an h will stay. So let me write over here, I want to say f prime of x equals the limit as h approaches 0 of, and now as I start canceling stuff, positive x squared, negative x squared. I can cancel those. 2hx. That has an h. There's no other negative version of that. That will stay. So in my numerator, 2hx. So now I've accounted for it. I'll cross it off. I'm done. H squared. There are no other h squares. It has an h. It will stay. So, and it's positive. So that's done. 3x. There's no h, so I should be able to cancel that. Here's another 3x over here. The first one's positive, and because of the negative in front of the parentheses, this one's actually negative. Positive 3x, negative 3x, they cancel. Gone. The next piece is 3h. It has an h, it can stay. There's no negative 3h to cancel it. So 3h, it's positive. And now at the end, 2. Here's another 2. Again, the first 2 is positive. The second 2 in red, because of the negative in front of the parentheses, is negative. So positive 2, negative 2. So I've done all of the denominator, and there's an h in the denominator. Now I have to take this limit, the limit as h approaches 0 of 2hx plus h to the second power plus 3h over h. Again, I still have that problem of the h in the denominator, which will zero the denominator. But now every piece in the numerator has an h. I can factor that h out and use it to cancel the h in the bottom. So now f prime of x equals the limit as h approaches 0 of, so if I take an h out in front, what I'm going to do is make some parentheses, pull an h in front of the parentheses. The 2hx will put 2x in the parentheses. The h to the second power will make an h to the first power in the parentheses. The 3h will give me a 3 in the parentheses. So now I've pulled out an h, and I still have the h in the denominator. Now the one I factored out in front of the parentheses and the one in the denominator can cancel. So now f prime of x equals the limit as h approaches 0 of 2x plus h plus 3. Now that we've removed the h from the denominator, there's only this one h left. I can let that run down to 0. So that limit is 2x plus 0 plus 3, which is really 2x plus 3. So f prime of x equals 2x plus 3. This little equation will tell me the slope of the original function anywhere I want. For any value of x I want, I don't even need to know what the graph looks like. So going back to the original question, part A says find the slope of f of x when x is 3. So take my f prime, the derivative, and we'll find f prime of 3 2x plus 3 becomes 2 times x is 2 times 3 plus 3. So I'm going to have 6 plus 3, 9. So when x is 3, the slope at that point is 9. And then how about the slope of the function when x is minus 2? So same process. Take my f prime of x and put in a minus 2. So f prime of minus 2 equals, the 2 times x will become 2 times minus 2. And then you have a plus 3 on the end. 2 times minus 2 is negative 4. So negative 4 plus 3 is minus 1. So for the function that we've done, x squared plus 3x plus 2, when x is minus 2, the slope at that point is negative 1.